What are neural prosthetics and how do they work? Imagine being able to control a robotic arm just by thinking about moving your own. Neural prosthetics make this possible by connecting the brain directly to external devices. These devices are designed to replace or improve functions of the nervous system that have been lost due to injury, illness, or neurological conditions. They work by interfacing with neural tissue, which includes the brain, nerves, or sensory organs. At their core, neural prosthetics detect signals from the nervous system or send electrical impulses to stimulate nerves or brain areas. For example, in sensory prosthetics like cochlear implants, an external microphone captures sound. The device then processes this sound and converts it into electrical signals. These signals are sent to an implanted electrode array that stimulates the auditory nerve. This allows the brain to interpret sound, even if the ear's natural parts are damaged. In motor prosthetics, neural signals related to movement intentions are recorded from the brain. These signals are decoded and translated into commands that control external devices like robotic limbs or computer cursors. This process is closely related to brain-computer interfaces, which decode neural activity to help people with paralysis or limb loss regain control over devices. Most neural prosthetics use tiny microelectrode arrays that are implanted into the brain or nerves. These arrays communicate wirelessly with external units, reducing the risk of infection or tissue damage. The devices are made to be as small and minimally invasive as possible. Power and data are transmitted wirelessly, so there are no wires running through the skin, which helps prevent infections. This field combines neuroscience, biomedical engineering, electronics, and robotics. Researchers aim to restore lost functions by either replacing damaged neural circuits or augmenting existing ones. For example, cochlear implants are the most common neuroprosthetic devices used worldwide to restore hearing. Motor neuroprosthetics enable control of prosthetic limbs or computer interfaces through motor imagery, where the brain's natural ability to imagine movement generates signals. These signals are then decoded to control external devices. Some neural prosthetics also restore vision or touch by stimulating relevant neural pathways. Others are used to treat movement disorders, chronic pain, or cognitive issues through neuromodulation devices. Overall, neural prosthetics are advancing rapidly, offering new hope for restoring functions that were once thought impossible to regain. They are a perfect example of how neurotechnology is transforming lives by bridging the gap between the brain and external devices.